Well, this is take 2. Evidently, I did not have my audio connected for take 1. So this is going to be the speed version because I really don't want to have to do this again. This week, we investigated magnets a little bit, and yesterday you were trying to figure out how a magnet can put a force on an object, like a paperclip, without even touching it. So we took some iron filings in class, if you were here, sprinkled them over the magnet. We didn't tap our table, but when we sprinkled it over the magnet, we could see that there was this pattern formed all around the magnet. What this is showing is that there is this field called a magnetic field that exists around a magnet. And that is how a magnet is able to put a force on something, like it's able to pull your paperclip without even touching it. It's because the magnetic field that it has interacts with or pulls the paperclip. So the magnet doesn't even have to be touching the paperclip in order to pull it. The magnetic field is. Okay? We can see this when you took and put two magnets together. You know that if you have two similar poles, like two magnets have a north pole and a south pole, if you put two south poles together and allow them to move, they will move away from each other. And when you sprinkled the iron filings over it, you can see why. It's because even though they're not touching, their fields are interacting and the fields are pushing against each other. Do you see how the iron filings in between the two magnets are kind of pushing against each other and then going out? So the magnets are pushing each other without touching because their fields are pushing against each other or repelling. Okay? So very interesting. A magnet has this magnetic field around it that can push or pull things without the magnet itself even touching objects. Let's turn our attention now to gravity. Today, we're just going to read a little bit about gravity and compare it a little bit to magnetic forces. And then next week, we're going to see what role gravity plays in the moon's orbit around Earth. Okay? So here's the definition of gravity. It says gravity is a force of attraction between objects that have mass. Let me read it again. It's a force, so a push or pull, a force of attraction, and it's between objects that have mass. So what that means is anything that has mass, no matter how small or big it is, exerts gravity or puts gravity on other objects with mass. So, for example, you have gravity, I have gravity, mass. Your pencil has mass, the earth has mass, the moon has mass, your computer has mass. Anything with mass then has gravity or this force of attraction between other objects with mass. Reading on, it says gravity can act between objects that are not even touching. Sounds familiar. In fact, gravity can act over very long distances. You are already very familiar with Earth's gravity. It constantly pulls you toward the center of the planet. It prevents you and everything else on Earth from being flung out into space as the planet spins on its axis. It also pulls objects that are above the surface, from meteors to skydivers down to the ground. Gravity between Earth and Moon and between Earth and artificial satellites keeps all of those objects circling around Earth. And next week we are going to investigate that a little bit more. How gravity keeps the moon circling around Earth. Today, though, all we're doing is thinking about what gravity is and how it compares to magnetic forces. So, in the chart here, all you have to do today is list some similarities between magnetic forces, which we've been investigating this week, and gravitational forces, which we will investigate more next week. And just think back to the definition of gravity and think back to what you know about gravity to come up with some similarities between magnetic forces and gravitational forces. And list those here. Like maybe one would be, they are both forces. Okay, then you can list a few. You can even add more columns if you would like. Then list some things that are different about magnetic forces and gravitational forces. So in this column, things specific to magnetic forces, like forces applied by magnets. Okay, and come up with some others that are unique just to magnetic forces, not gravitational forces. And then the last column, list some things that are specific to gravitational forces. Okay, so goal today, complete this chart where you compare magnetic forces and gravitational forces. We will explore gravitational forces more than next week. Happy Friday. Have a great weekend. As always, let me know if you have questions. Later.